Now let's do the inverse sine function. This one's pretty easy. We're given y is the inverse sine of x, and we want to find dy dx. So find the derivative of the inverse sine function. So here we go. I'll start off by taking this, and I'll take the sine of each side. And so that gives me sine y equals x. And now y is no longer an explicit function of x, but it is still a function of x. And this implies that it is a function of x, so we say it's an implicit function, and we can differentiate implicitly. So we differentiate each side with respect to x, and on the left we get cosine of y times y primed by the chain rule equals 1. Then we solve this algebraically for y primed. So y primed is 1 over cosine y. Now again, our original function was given in terms of x, so we would like to give this in terms of x, not in terms of y. And so a trig identity, once again, comes in handy here. And this one's easy. The trig identity is cosine squared y plus sine squared y equals 1. And let's just take this and solve it for cosine y. Cosine y is going to be the square root of 1 minus sine squared y. And let's substitute that back in right there. So y primed is then 1 over cosine y, which is this. The square root of 1 minus sine squared y. And this sine of y squared, remember, right up here, sine of y is just x. So this right here, sine of y squared, is just x squared. So we get y primed is 1 over the square root of 1 minus x squared. And we're done. And again, you could write it in the standard notation. The derivative with respect to x of the inverse sine of x is 1 over the square root of 1 minus x squared.